as we are preparing for your first and second derivatives test, make sure you fast forward to whatever you think is going to be the most beneficial for you as you're preparing for this test. Make sure you know how to do all these. Alright, what we're going to look for first, what can be determined from the original function, the derivative, the second derivative? Well, the original function, we want intercepts, x and y, asymptotes, both vertical and horizontal, and of course finding any domain, any breaks that we have possibly from setting the denominator equals 0. For the derivative, we can always find critical points. We use those to find max and min, and when we have increasing and decreasing. And of course, the derivative still always tells us slope. The second derivative, they will tell us points of inflection when we set them equal to 0. Those points of inflection deal with concavity, concave up, concave down. And then the second derivative test actually allows us to do maximums and minimums. So the first derivative test, all we need to say is, well, I'm going to set my derivative equal to 0. That's going to find my critical points. And then from there, all we're going to do is say, well, when the derivative goes from positive to negative, that means we have a maximum because we're increasing, now we're decreasing. When it goes from negative to positive, that's when I was decreasing, then increasing, that's when I have a minimum. Now, the second derivative test, we still start by finding the critical points again. So with the derivative equal to 0. Then from there, we take whatever this point was, whatever the x value is, so say x is equal to 1. I will then plug in 1 into the second derivative. If at that point the second derivative is bigger than 0, that means it's concave up, so that means that we must have then a minimum value at that critical point. Same way, if the second derivative is negative, that means it has to be concave down, which means my only possibility is a maximum there. Explaining Rolle's theorem, all we need to say is if I have the function values equal at 2 points, and it's a continuous function, then somewhere in the interval between these 2 points must be a maximum or a minimum. And the function needs to be continuous for this to happen. We also need a continuous function for the mean value theorem. And in this one, all we're going to say is if we connect 2 points with a secant line that goes between them, then somewhere between these 2 points, there is a spot where the derivative is equal. Where the derivative is equal to the slope of that secant line. So all we're going to say is that the derivative of f prime of x is equal to the slope of that secant line. So that happens like right there in that example. So use a diagram help you to explain 6, 7. Alright, so now we're going to use Rolle's theorem as we just described it. So all we need to say is this function continuous? Alright, so that's the first step. It is a continuous function. So what we're going to look for now is we want to plug in f of -2 and f of positive 6. They should equal the same number. And in this case they do. They both equal 0. So all we have to say is because f of -2 equals f of 6, and it is continuous, then a max or a min must exist in that interval. That's all you need to say. Now, to find the exact value when that happens, all we're going to do is set a derivative equal to 0. Well, the derivative in this case will be 2x minus 4, set it equal to 0. So that means 4 will equal 2x. It means my x value will be 2 for when in the interval it happens. And check and make sure 2 is within that interval from 0 to 6, or it should be -2 to 6. Alright, now use the mean value theorem to find the derivative value guaranteed on the interval from 0 to 6. So what this means is if we have this graph going from 2 points, what is the slope of that secant line? That is what's guaranteed to exist. So the slope, to find it, we need to do f of 6 minus f of 0 all over 6 minus 0. Well, f of 6, when we plug that in, we already found it, it's going to be 0. Minus f of 0 is 12. And then on the bottom, 6 minus 0 is going to be 6 minus 0 is 6. So negative 12 over 6, which equals, I should get 2. I apologize. This should be 0 minus, f of 0 is negative 12. So 0 minus negative 12. So 12 over 6, which is positive 2. So now, to find where that happens, when that derivative value happens, we're going to do the same sort of thing with the Rolle's theorem. We're going to set something equal to f prime of x. But instead of doing 0, we're going to use our number here, our derivative number from the secant line, 2. So 2 equals 2x minus 4. equals 2x or 3 equals x. That's the x value that I want. The next set is very similar. We want to, again, prove that a maximum or minimum exists on an interval. So negative 1 to 1, we're going to say the same thing. F of negative 1 equals a number. F of positive 1 equals a number. They're both 0. So because they equal each other, that means that a max or a min must exist. And we got to check, is it continuous on this interval? Yes, it is. We're going to look, discontinuities happen where? At x equals 2 and x equals negative 2, or where we have discontinuity. So a max or min exists because it is continuous on that interval. Okay, let's find the exact value where it happens. So 0 will equal f prime of x. So let's see if we can find what the derivative is. What we're going to do, quotient rule. So it should be low x squared minus 4 d high minus high d low, so x squared minus 1 times 2x all over low squared, x squared minus 4, the quantity squared. Okay? When we simplify that, we're going to expand. We're going to end up in the end with 6x on the top, negative 6x, and then x squared minus 4, quantity squared on the bottom. We still want to set that equal to 0. Well, the whole fraction equals 0 when this top equals 0. So that means negative 6x equals 0, or just x equals 0 is my answer for when the x value is. Number 14. Now we're using mean value theorem. When is it guaranteed on the interval from 1 to 4? So what I would do f of 4 minus f of 1 over 4 minus 1. Now I plug in and find my answer. However, pay attention though. This interval, 1 to 4, is it continuous on that interval? No, it is not, because in there we have this discontinuity at x equals 2. So the mean value theorem does not apply here. And it does not apply because we have a discontinuity we have a discontinuity in the interval. So discontinuity at x equals 2, which is in that interval that we need to worry about. Okay? So now, number 15, we want to use the mean value theorem to find it guaranteed on the interval negative 1, 0. In this case, negative 1, 0, there is no discontinuity in that interval. So I can set up this equation. So I'll do f of negative 1 minus f of 0 over negative 1 minus 0. Okay? So now I'm going to say, well, f of negative 1, we said 1, 0. F of 0, if we plug all that in, should be a 1 over 4 on the bottom, negative 1 minus 0. So I should get, when I simplify that, to 1, 4. So to set up the equation in the end, I want to say that 1/4 equals my derivative. The derivative function I just found, which was negative 6x over x squared minus 4, the quantity squared. And it doesn't ask you to solve it, it just asks you to set it up, because that would be a quite difficult one to solve. Alright, now, first derivative. We want to find critical points of f of x. So, to do that, we need to take a derivative. F prime of x equals what? It would be 4x cubed minus 24x squared minus 64x. I'm going to factor out a 4x, which leaves me with x squared minus 6x minus 16. I can factor that, so it will be 4x times it's x minus 8 and x plus 2. So, if I wanted, what I need to do is finding critical numbers, critical points, is setting it equal to 0. So x equals 0, 8, and negative 2. To find the points, I need to plug back into my original equation. So my points are, for 0, it's 0, 0. For 8, when I plug that in, it's 8, pretty negative number, to negative 2048. And then negative 2 becomes negative 24. So those are my critical points. If I said just critical numbers, R means the x values. Alright, now I want to use that first derivative to find mins and maxes. Which ones are the mins, which ones are the maxes. So with my number line, I need to do negative 2, 0, and 8, because those are my critical numbers. And I need to do tests on each side of these intervals. Well, when I plug in like negative 3 here, we'll have a negative times a negative times a negative. Gives me a negative number here. I plug in negative 1. Negative times negative times positive. Gives me positive. This one here will be negative. This one here will be positive. Again, this is positive 1. This will be positive times negative times positive. and then all of them will be positive for the last one. So that means that my relative maxes occur when I go positive to negative. So that means my maximum will occur at x equals 0, so the point 0, 0, and I'll have minimums at the other 2 points. So at 8, negative 2048, and at negative 2, negative 24. Those are my mins and maxes. Okay, now when is it increasing and decreasing? I can read that straight from this chart as well. It's increasing on the interval negative infinity to negative 2. I'm sorry, that's when it's decreasing. It is decreasing on negative infinity to negative 2, and also on 0 to 8. As for when it is increasing now, when is it positive? That's the derivative positive from negative 2 to 0 and from 8 to infinity. Let's look at another one. Okay, we have, this is y, or f of x equals x cubed over x squared minus 9. So try to get you one of each to look at. One is a polynomial, one is a rational. To find critical points, again, we need to take a derivative. So I'm going to take g prime of x, and I'm going to set it equal to 0. To do this, I'm going to do low d high. So low, x squared minus 9, d high, 3x squared, minus high, d low, all over low squared, which is x squared minus 9 squared. I'm going to expand it, then I'm going to reduce it. I end up getting, on the top, x to the 4th minus 27x squared, all over x squared minus 9, the quantity squared. Now, I can pull out an x squared up top, so I'll have x squared times the quantity, x squared minus 27, all over, same on the bottom, x squared minus 9, the quantity squared. To find critical points, I need to say when is that equal 0, so I'm going to say x squared times x squared minus 27 must equal 0, because that's what the numerator is. That means x equals 0, or I can also say x squared minus 27 equals 0, which means x will equal plus or minus the square root of 27. Okay? Those are my critical numbers. Don't worry about finding the points. You can just approximate that the y value for those would be about 7.8. Don't worry too much about finding the critical point in this one. You know how. You just got to plug it back in. In this case, it gets to be a pretty ugly number. Now, we're going to use the first derivative test to find minimums and maximums. So, what we need to do is first, we need to plug in our critical numbers. We have 0, we have negative square root of 27, and we have the positive square root of 27. Now, we also need to look at where are their domain issues. Well, there are domain issues at x equals plus or minus 3. So I should also look here at negative 3 and positive 3. These are where I'm going to have vertical asymptotes here. So we need to look at all of these different intervals. And when I do this, well, no matter what I plug in, x squared in my derivative will always be positive. And over here, so really all we need to look at is x squared minus 27. So if x squared is bigger than 27, we'll have a positive value. If x squared is less than 27, we'll have a negative value. Well, it's bigger than 27 on the outer region. So say something bigger than square root of 27 would be, say, 6. 6 squared minus 27 is positive. Negative 6 squared minus 27 is positive. All these other regions end up being negative no matter what I plug in. So that means that my maximum will occur, and we should say them as points, so my maximum should occur at when I go positive and negative. So that's going to occur at square root of 27, comma, whatever the y value was for that, which was 7.8. And then my minimum, when I go from negative to positive, is at positive square root of 27, negative 7.8, which you got just by plugging back in. Alright? And then that means we still have this other critical point at x equals 0. Well, that means going from negative to negative tells you absolutely nothing. This means it was decreasing, it leveled off, and then it decreased again. So it's not a maximum or a minimum in this case. Then the last step, when is it increasing, when is it decreasing? Start with increasing. Where is the derivative positive? Negative infinity to negative root 27, and also root 27 all the way up to infinity. All these other intervals in between are when it's decreasing. So negative root 27 to negative 3, also then from negative 3 to 0, from 0 to positive 3, and from 3 to root 27. Those are all the intervals that you can come up with in terms of being positive or negative. Alright, last page here, we're going to do now the second derivative test. So, to do first the critical points, again, f prime of x equals 0. So the derivative is 3x squared minus 6x. I'm going to factor out a 3x, leaving with x minus 2. So when I set it equal to 0, I'm going to get x equals 0, and x minus 2 equals 0, so x equals 2. 0 and 2 are my critical numbers. When I plug back in, I should get the points 0, 3, and I should get 2, negative 1 as my critical numbers, my critical points, I should say. Now, to do the second derivative test, I first will need to take a second derivative. So f double prime of x, which will equal 6x minus 6. What I need to do is I'm going to test by saying what is f double prime of each critical number. So f double prime of 0 and f double prime of 2. At f double prime of 0, I'm going to get negative 6. And at f double prime of 2, I am going to get a positive 6. Alright, when it's negative here, that means it is concave down. And if it helps to draw a picture, do so. If it's concave down, it looks something like that, which means that that number must be a maximum. So it's a maximum at the point 0, 3. This one here being positive means it's concave up, which again, if you look at your picture, should look something like that, which means it must be a minimum value then at the point 2, negative 1. Alright, now to find all points of inflection, all we do with points of inflection is to set f double prime of x equal to 0. Well, f double prime you said was 6x minus 6. That means 6 equals 6x, or x equals 1. If x equals 1, I'm going to plug in back to the original equation. When I find a point, critical point or point of inflection, I need to go back to the original. So that means that my point here is going to end up being 1, when I plug that in, 1. And see if it's concave up or down. Another number line here. My only point of inflection is 1, so I'm going to plug in 0 for my second derivative. If I plug in 0 here, I get a negative value to the left. If I plug in 2 over here on the right, I'll get a positive value. So that means that it's concave up on the interval from 1 to infinity, and then it's concave down on the other interval, which went from negative infinity to positive 1. And again, there are no domain restrictions, so we don't need to worry about that for this one here. Alright, the last one, finding vertical and horizontal asymptotes here. Well, vertical asymptotes are when the denominator equals 0. So, x squared minus 4 equals 0. That's going to be the same as if we factored x minus 2x plus 2. So that means vertical asymptotes will occur when x equals plus or minus 2. Horizontal asymptotes. We look at the powers of the highest power, it's both 2. So that means we need to look at the coefficients of those numbers, 3 and 1. So horizontal asymptote occurs at 3 over 1, or just y equals 3. Now the last one, finding points of inflection. I just wanted to do this to see how you're getting more practice, I should say, with your quotient rule here. So we're going to do low d high, so x squared minus 4 times 6x, minus high d low, 3x squared times 2x, all over low squared. So that's x squared minus 4 quantity squared. I'm going to expand this. I'll go through a whole step. 6x cubed minus 24x minus 6x cubed, all over x squared minus 4 quantity squared. Simplify that one more time. I'll get negative 24x on the top, and I will get x squared minus 4 quantity squared on the bottom. That's the first derivative, points of inflection. No, I need second. So f double prime of x equaling 0. Alright? What we need to do here is low d high. So x squared minus 4 quantity squared, d high of, we want to look back to this function. So d high here is negative 24. Minus high d low. So minus negative 24x d low will be chain rule. So 2 times x squared minus 4 times 2x. And then all that will be divided by low squared, which is x squared minus 4 squared squared means to the fourth power. Now here's the trick when we're doing this. I have x squared minus 4 in each of the terms up top and the denominator. So make that cubed on the bottom, get rid of this one, and get rid of, so it's only 1 there. What that means now that I have left, I can now distribute in here. I get negative 24x squared. This becomes plus 96. This minus and then all negative, I can think of that as plus a positive. So we're going to have plus, and this will become 96, or 96 was here, I'm sorry. So I have 24 times 2 times 2, which should give me, let me make sure I get this right. So this should become plus a 96x squared, yes, divided by still x squared minus 4 to the third power. See if I can simplify this any bit. Well, 96x squared and minus 24, I can combine that to be 72x squared plus 96 all over x squared minus 4 to the third power. And that's probably about as simple as we're going to get. To find points of inflection, I need to set this equal to 0. Does this numerator ever equal 0? Well, this is always positive, and I'm always going to add 96 to it. So there are actually no points of inflection here because we're never going to get a case where the numerator, so the entire function here, equals 0. So in this case, there are no points of inflection. Well, there you have it. Hopefully you're in good shape for this part of the test. Remember, it is going to be something that you need to just take your time on, and you'll do just fine. Just, you know what you're doing, I promise.